decreased by 3 is 42. What would that look like as an equation? Well, I guess the first thing I should ask, why do I know it is an equation? What two-letter word in there is telling me it's an equation? Is, right? Okay, so twice a number decreased by 3 is 42. All right, let's use x as our number. Just make it standard. So if I wanted to do twice a number, what would that look like? 2x. Good.
So 2x minus 3 equals 42.
Yeah, so twice the number is being decreased. So decrease tells me I'm going to be doing subtraction. So minus 3, that word is, gives me that equal sign, 42. Would you be able to solve that equation?
Yeah.
I hope so. You don't have to do it. I hope you would be able to do that. Okay? So translating words into algebraic equations or expressions. What's the difference between an equation and an expression? What does an equation have that an expression doesn't have? Equal sign. Good. So just 2x minus 3 would be an expression, right? All right, so let's try this one out. The product of a number and 12 decreased by 7 is 105. So product means we're going to do what? Multiplication. What two things am I multiplying? 12x. Perfect. Why would I not write x12?
Because that's just not how they work.
That's just, yeah. You want 12 to be the coefficient of the variable, right? So it's in front. All right, so 12x is decreased. So we're going to do minus 7 equals 105. Good. What would have changed if this word said quotient instead of product? It would, instead of 12x, it would be 12 over x, if you wanted to make it like a fraction, right? Good. All right. Problems 7 through 15 odds are like that for your homework. You think you guys got that?
Yes.
Are we sure? So we can jump to the fun stuff, which is the word problems? Okay. All right. So here we go. I'm going to skip all those, jump to a word problem. Here we go. The length of a rectangle is 1 centimeter. Oh, it's taking us back to geometry days, huh? So the length of a rectangle is 1 centimeter more than twice the width. And then they're telling us the whole entire perimeter is 110 centimeters. So we need to find the dimensions of that rectangle. Okay, so the length of a rectangle is 1 centimeter more than twice the width. The perimeter of the rectangle is 110 centimeters. Find the length and the width of the rectangle. Okay. I like diagrams, so I'm going to make myself a fancy rectangle down here. Not too shabby. Usually, which is longer, the length or the width? The length. Good. All right, so if the length of the rectangle is 1 centimeter more than twice the width, what would that look like as an algebraic expression? 1 plus 2w. Sure, we can do that. 1 plus 2w. So then what would be the expression for the width, if that's the length? Maddie? Stretching? It would just be w, right?
And then the way we would find the answer is we add up all the sides and set that equal to 110.
Perfect. Okay, so you got two options. We can fill in the rest of this rectangle with all of its dimensions. And you can literally add up all your constants, add up all your variables, and equal it to your
That'd be
perimeter.
6W plus 2 equals 110.
Perfect. Okay. Or, do you guys remember from yesterday what the formula for perimeter of a rectangle is? P equals 2L plus 2W. You could do it that way. Me, personally, I would just add them all up.
Yeah.
Because that's easier than plugging it in there and distributing on 2 on both ends, right? All right, so if we just add up our constants, 2W plus W is 3W, plus another 2W is 5W, plus another W is 6W. So I get 6W, plus the only constants I see are these two ones, so 1 plus 1 is 2, equals my perimeter, which is given to us, which is 110. Solve that equation for W. I gave you guys 4. I'm going to give you one more back. What are we getting for the width? 18. Don't forget your units. Whenever we're dealing with word problems, you're most likely going to have units. So we're dealing with what units here? Centimeters. Okay, so we've got 18 centimeters for the width. What's the length then going to be? Huh?
37.
30.
Wait.
Well, 110
Oh,
minus
yeah.
18 is what?
92?
92?
Yes.
Yeah. Right? How many short ones? Are there extras anywhere? Did I give anybody more than one? How did I not print off enough? Alright, I'll print one out for you. Or who wants the answer key? How do I not have enough of these? Or maybe I don't know. All right, give me 2 seconds. Aren't or they are?
They are.
Yes. So it says the width of the top floor measures 20 feet more than 1/2 its length. What does that look like as an expression? 20 feet more than 1/2 its length.
X over 2 plus 20.
Sure. Oops, x over 2 plus 20. Or if you used L for length, that would work too. So if that's my width, what's going to be my length? Just x. Good. So this is x. This is x over 2 plus 20. All right. Add up your x's. Let's do these first. What's half an x plus half an x? 1x. Plus the other 2 x's make how many x's? 3 of them. Perfect. So we end up with an equation of 3x plus how many constants? 40. Good. Equals 520. Good. Solve that out. Get your length and your width dimensions. Did we get 160 and 100? 160 feet for your length, 100 feet for your width? Yes? All right. Can we move on to the next one? Okay, back to our
You
notes.
said.
Second type of problem. You said no?
No, shoot.
I'm sorry.
That's okay. So we end up getting x ends up equaling 160 when you solve that. So 160 feet by 100 feet. All right, so back to our second type of example. Okay, I updated that. This was from our book, but I updated it. Our book's got old examples in it, if you haven't figured it out. It's like 2004 or whatever it is. So I found the 2017 stats. So apparently, I don't watch baseball, but apparently 2 outstanding Major League pitchers in 2017 were Clayton Kershaw from the Dodgers. Is that right? And Max Scherzer from the Nationals. So combined together, they had 407 strikeouts. Scherzer had 57 more strikeouts than Kershaw. How many strikeouts did each pitcher have? What would you do? So let's look at this sentence right here. Scherzer had 57 more strikeouts than Kershaw. How would you write that as a expression? Kyle, where'd you go?
So would you just put in x plus 57?
Sure. So if we do x plus 57, this right here represents which person?
Kershaw.
Scherzer had 57 more strikeouts than Kershaw, right? So this right here is representing Scherzer, right? Okay, with me so far? Together, Scherzer plus Kershaw should have how many total strikeouts? 407. So what expression would represent Kershaw? Just x, right? So we have x plus 57 plus x, which is our Kershaw expression, equals 407. That's a pretty simple equation to solve, right? Go ahead and solve it for x. Two x plus 57 equals 407. 407 minus 57 is, oh, my battery just died, 350 divided by 2, it's 175. So who has 175? Nevin? Nevin, you got that many strikeouts?
Yes.
Okay. So Kershaw had 75 strikeouts? That's according to Google, if we believe Google. And then Scherzer would then have how many? 407 minus 175 leaves us with 232 strikeouts. So there's our answer. So go ahead and try the second one of the try your own problems. About Broadway musicals. If you are stuck, you can go ahead and look at the front board. So your Phantom performances plus your Les Miserables, right? Is that how they say it?
Les Miserables.
The French. Is a combined total of 18,998. It said that your Phantom performances, there were 5,638 fewer performances of Les Mis than Phantom. So there's that expression for your Les Mis. X would be your Phantom. Combine your like terms. 2x minus 5,638 is equal to 18,998. Add it over. So what do you get x to be? Yeah, 12,318. How would you label that? What are your units? what is that? It's performances, good. Performances of your phantom. So then how many Les Mis performances?
How did you do that?
Huh? I solved this equation for x, combined like terms. So x plus x would get you to 2x,
Oh,
right?
sorry.
That's okay. Add the 5,638 over. And then what was Les Mis? 6,680?
Yep.
Good. All right. Good, good, good. Okay, example 3. 2017, which is now. There are currently 293 area codes in the U.S., which is an increase of 241% over the number when the area code plan originated in 1947. We need to figure out how many area codes were there in 1947. Do you know how area codes were created?
No.
So back when they had dial phones, like rotary phones, that spun around. Have you ever used one of those before or seen them? Probably never used one before. They gave the places that had the most population numbers that were closest to the first spins. So that's why places like New Hampshire got 603, because those were 0 was all the way over, so you had to spin it all the way around. So unpopulated places got the higher digits because it was less movement of your fingers.
Wow.
So they were just trying to let people be lazy. Isn't that crazy? Anyways. Okay, so area codes started in 1947. We don't know how many area codes there were in 1947, but we know that there was an increase of 241% in the whole stretch to 2017, which there are now 293 area codes. So, how do you think we could set this up as an equation? Barry, what do we do?
X, what I did, I'm not sure if this is right, is x times 2.41 equals 293. Because an increase of 241% would be multiplicative.
All right, you're close. I'm going to write that down so far. Why'd you say 2.41?
Because 241%, and you got to convert it to a decimal or to multiply
Perfect.
it.
All right, so if we write 2.41x equals 293.
I divided 293.41x, and I got 121.576.
Okay, so now let's think about this. That would get you just a percentage of some number. Let's first think about what x represents. What does x represent? Area codes that were there in 1947, right? So x represents your area codes that were there. I'm getting an increase. So that means I probably should have what type of operation in my equation? Increase.
Division.
Increase would be addition, right? Because you're increasing, so you're adding. So I have my original, so your original 1947 number, which is your x, and then we need to add to it our increase of 241% is going to equal your 293. So that's going to be your actual equation. Is that what the hand over there was all about? No? What was the question?
I was just trying to solve it.
Oh, okay. Okay, so that's the equation we want to do. So how do we solve that equation? Combine the x's. So 1x plus 2.41x gets us 3.1 or 41x equals 293. Divide that, what is it? I don't know what that is.
85.92.
85.92.
Yeah.
So let's round it to 86. So 86 area codes in 1947. Okay. All right, now the one that's on the try your own, and then we'll just stop here because we're out of here at 27. Got 5 minutes. There is a typo. Your college tuition has increased much more than 109%. So in 1995, the average cost of tuition and fees of a public four-year universities in the U.S. was $2,811 for full-time in-state students. That'd be nice, right? By 2017, change year 109 to 1,009.
That's a pretty big difference.
That's a pretty big difference, yes.
I wish it was 100.
To the nearest dollar, what is the approximate cost in 2017? So how are we going to set this one up? So we are going to do increase again. Risen. Risen's kind of the same word as increase. So we know we're going to have a plus. So we're going to have that original tuition, which will make X. Or actually, we know the original tuition, don't we? Don't make that X. Your original plus your increase is going to be equal to your 2017 cost,
Just X.
which will be your X. So this one's going to be nice because we're not going to really have to solve anything. So we want to find the approximate cost of 2017, which is your X. My original is how much money? 2,811 plus what's going to be the expression for the increase?
Would it be 2,811 multiplied by 10.09?
Yeah, 2,811 times 10.09 is going to be equal to X, and that's just calculator work right there. So I would just put that in, nice big string in my calculator, 2,811 plus 2,811 times 10.09. What's our average cost now? It's going to be depressing. I'm sorry to leave you in this depressing mood.
31,173.99 cents.
Say the last three again. 31,000.
173.99 cents.
99 cents. There you go. All right, so we will stop